Hello friends, welcome back to our YouTube channel. If you like this video, please like, share and subscribe. I'll share our videos commanded by our experts, so let's begin.
If you like, please like, share and subscribe. So let's begin our today's topic. Let's begin.
Over the last year, a highly publicized wave of mass layoffs swept through big tech, eliminating thousands of software engineers and corporate white-collar roles. Behind that digital contraction is a hidden countertrend. Hundreds of millions of dollars are actively flowing out of corporate offices and into physical infrastructure. This dual-axis chart illustrates the specific targets of that spending. As white-collar headcount drops, tech funding is surging into blue-collar infrastructure, specifically electricians, welders, and HVAC technicians. Companies that built empires on intangible code are now operating like heavy industrial construction conglomerates. Software innovation is no longer the primary limiting factor in the AI race. The code has outpaced the concrete. This aerial shot shows a massive data center complex under construction. It visually demonstrates the true ceiling on artificial intelligence, the physical construction, power routing, and thermal management of these hyperscale facilities. Pure software companies have historically scaled by renting server space. They have never faced industrial supply chain friction and physical land development at this scale. Dominating artificial intelligence now requires mastering heavy industrial logistics, merging the software business model with the physical requirements of heavy industry. To understand why this physical bottleneck exists, we have to track an advanced AI system from the moment it generates a prompt. This image shows the immediate physical layer of AI computation. A digital prompt originates here, inside these glass-enclosed server racks housing densely packed GPU clusters. High-performance compute running continuously at this density generates enough thermal load to damage silicon components in minutes. It is a strict thermodynamic problem. Standard air conditioning fails under this thermal load. Notice the hardware in this photograph. Specialized liquid cooling networks and heavy overhead pipes must be physically suspended above the server racks to prevent the hardware from overheating. Those thermal systems must be wired directly into the electrical grid. A massive baseline power draw is required solely to keep the liquid cool, entirely separate from the electricity used by the GPUs themselves. Billions of dollars in advanced AI chips sit completely idle in warehouses because the physical facility lacks the power or cooling capacity to turn them on. A single delayed chilled water pipe or unfinished electrical substation effectively halts a multi-billion-dollar AI deployment. The specialized tradesperson is the ultimate gatekeeper of compute capacity. That requirement for physical infrastructure collides directly with the demographic reality of the American labor pool. There is a severe, quantifiable supply limit on specialized physical labor in the United States. This line graph tracks the rising median age of tradespeople, projecting an accelerating wave of retirements. This exit of labor intersects with a demand-side shock. The vertical spike represents data center construction, currently eclipsing standard commercial real estate demand. The intersection of retiring experts and skyrocketing corporate demand creates a timeline that technology companies cannot meet organically. Furthermore, this wide shot of a snowy rural development site emphasizes the conditions of the work. Data centers require rugged logistical operations, heavy machinery, and physical labor in remote or extreme weather environments. Relying on organic labor market corrections, waiting for a new generation to naturally enroll in trade schools, is too slow for the cadence of the AI arms race. Tech giants face an existential threat to their deployment schedules. They cannot simply buy their way out with higher construction bids because the necessary workforce literally does not exist. To solve this, technology companies are bypassing traditional labor markets to manufacture the exact workforce they need. Meta launched the America's Workforce Academy. It is framed as public outreach, but operates as a direct corporate intervention securing human capital. This map shows Meta's $115 million initiative. They are fully funding 5-week training programs piloted in Louisiana, Ohio, Indiana, and Texas. The critical mechanic is the final step. Graduates are guaranteed deployment directly to their own construction sites, creating a closed-loop labor system. Google is employing a similar strategy, executing a $50 million nationwide investment in physical trade programs. Rather than building a separate academy, Google is injecting a $10 million grant directly into existing union-backed electrical programs. Their quantitative objective is to expand the regional pipeline of skilled electrical technicians by 70. If Meta or Google secures an exclusive pipeline with local trade unions, rival AI companies lack the personnel to build in that same region. These multi-million-dollar training initiatives function as strategic supply chain acquisitions. The goal is to hoard the rarest commodity in the modern tech sector: physical labor. The modern tech monopoly requires an entirely new organizational structure. This 3D stack model illustrates how vertical integration applies to 21st century compute. AI software and algorithms sit at the top. Compute and server hardware sit in the middle. The foundational layer is proprietary infrastructure labor. The separation between a software company and a heavy industrial conglomerate no longer exists. The upper layers of code cannot scale without a secured physical foundation. The machinery in this footage reflects the industrial titans of the 20th century. Monopolies in rail or steel had to purchase raw material sources and physical transit lines to guarantee their dominance. Hyperscalers are running the exact same playbook, applied to human capital. They are securing welders, pipe fitters, and line workers. While market attention focuses on benchmark tests and algorithmic efficiency, the actual constraint on the industry is being fought on gravel lots and construction sites. Billions of dollars spent on AI research yield zero return if the servers melt down or the regional power grid fails. For industry analysts evaluating the market, the long-term winners will not be determined purely by code. The ultimate competitive moat in artificial intelligence is the proprietary pipeline of blue-collar labor required to keep the machines alive. To scale artificial intelligence, the tech industry first has to coordinate pouring millions of tons of concrete and welding heavy steel. Over the last 18 months, the largest technology companies in the world executed a series of aggressive workforce reductions, eliminating tens of thousands of white-collar corporate roles and software engineering positions. Concurrently, those exact same corporate balance sheets show billions of dollars in capital expenditure being forcefully redirected into heavy industrial construction. The primary constraint on the deployment of advanced language models is no longer the availability of computing power or a deficit of coders. The physical limit on AI scaling is a severe national shortage of specialized human capital, high-voltage master electricians, heavy pipe welders, and commercial HVAC technicians. To secure these specific workers, companies like Alphabet and Meta are bypassing traditional hiring channels entirely, instead funding their own free regional trade schools to manufacture a labor supply. By looking at the raw mechanical constraints of modern data centers, we can track exactly how corporate capital is flowing into local trade unions and examine the highly accelerated mechanics of these new academies. The barrier to entry for the tech sector is moving. The immediate requirement is assembling the physical infrastructure that makes the algorithms possible. Housing and running advanced AI models requires a massive physical footprint that dominates hundreds of acres of open real estate. Standard cloud servers operate at a relatively low power density. An AI server rack packed tightly with GPUs draws up to 5 times the electricity of traditional enterprise hardware. Supplying that power density requires custom, high-voltage electrical rigging. Safely routing that level of current through thousands of server racks without triggering a localized grid failure requires highly specialized installations. The immediate byproduct of this extreme power density is massive thermal output that constantly threatens to melt the hardware. Mitigating that heat requires advanced liquid cooling arrays and highly specialized HVAC systems integrated directly into the building's architecture. Standard commercial real estate crews, equipped to build standard logistics warehouses or office parks, lack the certifications for these hyper-specific cooling and electrical tolerances. When specialized crews are unavailable, construction simply halts. AI companies face extreme deployment delays, stuck waiting months for qualified teams to arrive on site. The backlog spans the country, with multiple billion-dollar facilities currently sitting partially exposed, paused indefinitely waiting for labor. AI's theoretical computing ceiling has collided directly with the rigid limits of physical engineering. Without securing a reliable pipeline of highly specialized blue-collar labor, billions of dollars of AI hardware remain completely stranded. This delay is exacerbated by an underlying demographic crisis currently crippling the American skilled trade sector. This line graph tracks the median age of traditional skilled trades workers, such as electricians and pipe fitters. Over the last 20 years, the trend is a steady, uninterrupted climb. The data points to an imminent retirement cliff. A massive cohort of master-level technicians will exit the workforce entirely within the next 5 years. Overlaying that labor data with this bar chart reveals the problem: a rapidly shrinking labor pool contrasted against a surging demand curve created by the data center construction boom. Traditional vocational schools and public apprenticeship programs are mathematically incapable of producing master-level replacements fast enough to close this specific gap. Big tech operates on product iteration cycles measured in months, while a national labor force requires years to naturally replenish itself. Relying on legacy educational pipelines guarantees strategic defeat. To maintain their build schedules, AI companies are forced to take direct control of their labor supply. This marks big tech's strategic pivot from being passive hirers of talent to active developers of human capital. This Sankey diagram illustrates the scale of the financial intervention. Capital originates from tech entities and splits into direct investments, like Meta's $115 million initiative and Google's $50 million pledge. Google's $50 million investment diffuses across various trade programs across the U.S., actively subsidizing local training infrastructure. Isolating the data reveals a specific $10 million carve-out directly for union-backed electrical programs, carrying an explicit goal to expand the pipeline of skilled technicians by 70%. Microsoft and Oracle are heavily adopting similar blueprints, pushing their own capital into regional initiatives. These companies then form exclusive partnerships with massive regional construction firms, ensuring that the talent produced by these investments flows directly to their own sites. This sudden influx of massive tech capital is rewriting the financial stability and the operational capacity of local trade unions. These investments allow tech giants to engineer regional labor monopolies, securing the infrastructure needed to outpace competitors in the AI race. Looking past the macroeconomics of the funding, the ground-level mechanics of these corporate academies reveal exactly how they operate. Meta's America's Workforce Academy serves as the premier case study for this highly optimized talent pipeline. This map of the United States shows the program's strict geographic targeting. Qualification is limited exclusively to Meta's 4 active construction zones: Louisiana, Ohio, Indiana, and Texas. To rapidly fill classes, the $115 million initiative removes all financial friction, making the training program completely free for accepted candidates. This timeline graphic contrasts the curriculum's main structural advantage, the hypercompression of training time. A standard vocational path is condensed down into Meta's 5-week block. A 5-week timeline strips away broad theoretical education. The curriculum focuses entirely on specific, site-ready deployment skills required for immediate utilization. The ultimate endgame and the primary draw for local recruits is the guarantee of job placement upon completion. Graduating from the academy channels workers directly to active Meta data center sites, entirely bypassing standard HR application processes and interviews. This deployment matrix solves the logistical friction of finding, hiring, and relocating specialized labor to hyper-specific geographic build sites. Compared to the bloated hiring processes of traditional corporate divisions, this 5-week funnel operates with raw industrial efficiency. Accessing the tech industry now depends on entering Meta's hyper-local, hyper-accelerated physical supply chain. Forecasting the tech industry over the next decade reveals a labor force drastically different from the one that built the internet. The digital network powering these artificial intelligence models is now permanently inseparable from a massive, heavy industrial footprint. The corporations that successfully build the most efficient blue-collar talent pipelines will physically dictate the pace of the AI race. As software becomes increasingly automated and digital tasks are outsourced to language models, the valuation for skilled physical labor permanently increases. The era of software coding boot camps is fading, rapidly replaced by the rise of union-backed, corporate-funded trade academies. AI may soon write internal code, but it cannot pour concrete foundations, and it cannot weld cooling pipes. Big tech has evolved from holding software monopolies into operating as massive blue-collar infrastructure developers. The ultimate builders and the primary beneficiaries of the artificial intelligence revolution will wear hard hats, not headsets.